Hey everyone, welcome back. In this lesson we're going to continue with the topic that we started last time out, which was exponents. So we're going to be working more with exponents today. Now we covered most of the basics in the last video, so you can always go back and re-watch that if there's anything you want to review. But if not, then hopefully we're ready to move on to well, mostly just practice problems of the things that we did last time, but a couple of slightly more involved problems than what we were doing before. And we'll utilize one new rule that we didn't talk about last time with exponents. So last time we were talking about some exponent rules that, and I was writing them out with letters. So things like a to the exponent b times a to the exponent c is equal to a to the exponent b plus c. So things like that. We'll end up making use of some of that in a couple of problems today. We might not use everything that we talked about in the last video, but that's because I want to introduce one new things as well, one new rule that's sort of, we'll introduce it in the same way as those ones. We'll use the letters and then we'll do some examples. But first we'll just go through a few examples of just doing some calculations involving exponents, and then we'll worry about those rules a little bit later on. So if we want to do some calculations with those, so let's start with something like 7 to the exponent 3. So just a bit of a refresher, remember that this 7 down here, the big number, is called the base, and then the little guy up there is your exponent. So we want to use, we're going to be writing down the base over and over and over again, and the number of times that we're writing down that base is dictated to us by that exponent. So if it's a 3, we'll write it down 3 times. If it's a 7, we'd write it down 7 times. If it's an 11, we'd write it down 11 times. And then we'd multiply all of those bases together. So in a problem like this one, we're starting with our base is 7, so we know we're going to be writing down a bunch of 7s, and we're only going to be writing 3 of them because that's what our exponent is telling us up here. So I'm going to write down a 7 here, a 7 here, and a 7 here. And so we're going to multiply all of those together, and once we compute that product, we'll have our final answer. So we start with, so that we've turned 7 to the exponent 3 into 7 times 7 times 7, and now we want to calculate that product. So we'd start with 7 times 7 here, that's 49. So we've got 49 as 7 times 7, and then we want to figure out what's 49 times 7, and we can go back to our handy-dandy long multiplication to do that. 7 times 9 is 63, 7 times 4 is 28, plus 6 is 34. So you should get an answer of 343. Now we've used up all the 7s, right? We use this one, 7 times 7 is 49, times 7 is 343. So once you've done the multiplication with all of those bases, once you've used up all of the bases once each, then you're done, and you can write down your final answer over there. So then we get that 7 cubed is 343. So that's just a bit of a refresher of what we were doing last time. We'll do another one. Let's set this up with, what do I have over there? Okay, so what we'll do this time is we'll take a slightly larger base, so we'll take 12. Now I don't want this to get overly messy, so I'm going to keep the exponent small. So we're going to make the exponent just 2, so it's going to be 12 squared is what we want to find out. And so we're going to take this base is 12, so we write down 12 twice, and the reason we write it twice is because of that 2 right there. If this was a 3, we would have added another 12 over there. If this was a 4, we'd have 2 more 12s over there, and so on. So because we've got an exponent of 2, we write it down 2 times, and then we multiply those together. So then we want to figure out 12 times 12. You might already know this. If not, you can calculate it using long multiplication or punch it into a calculator, and it should give you 144. So that should be your final answer for 12 squared, or 12 to the exponent 2. So we'll do one more practice problem. This is sort of just to refresh your memory before we go on to something a little bit harder. And this one, let's change it up just a little bit. We'll use one of the rules that we talked about in the last video. So we're going to figure out 4 squared squared. So it's going to be 4 squared and then the whole thing squared. Now if you remember from our exponent rules, if you've got a power, so something with a base and an exponent, and then you raise that whole thing to another exponent, then you can just take those 2 exponents and multiply them together. So our power here is that 4 squared, and then our exponent, that whole thing is raised to the exponent 2. So we can just take this exponent here, this 2, and that exponent out there, that 2, and just multiply them together. So instead of 4 squared squared, it's going to be 4 to the exponent 2 times 2, which is going to be 4 to the exponent 4. And now we can go and calculate that. That'll be, I'm going to run out of space here, but that'll be 4 times 4 times 4 times 4. So we're going to multiply 4 by itself a few times there. So we've got 4 times 4 times 4 times 4. So you could do this 2 ways. Your one option is that you do it as 4 times 4 is 16, times 4 is 64, and then multiply that by 4. Your other option would be you do 4 times 4 over here, and then you do 4 times 4 over there. So you use the other 2 4s, you get 16 here, 16 there, and then multiply those together. So whatever way is more comfortable for you to actually do that multiplication, that's totally up to you. But you should be getting a final answer of 256 for this one. So I'm going to erase these just because I want to highlight that point that I was making a little bit more clearly than just off to the little corner of the board. So basically what we started with was 4 squared all squared, which is the same as 4 to the exponent 4. Now, if you're looking at that power in this form, 4 to the exponent 4, you might not notice offhand that that's the same thing as 16 squared. I mean, if you write it out, then you'll get 4 times 4 times 4 times 4, which if you do this multiplication, you'll get a 16. If you do that multiplication, you'll get a 16. Then you multiply those together, and you'll get 256 as your answer, which is 16 squared. But if you have it written in this form, you might notice, okay, well, 4 squared, I know that part's 16, and then that thing has to be squared. 16 squared, maybe you know it off the top of your head, is 256, and you're done, just like that. You might not know 16 squared off the top of your head, so that might not be quite as useful as it seems, to me right now, but that's an option. If you know the thing in the brackets here, you don't have to abide by that rule to get it down to just one exponent. You might recognize 4 squared is 16, and then I can do 16 squared and it'll give me 256. This way you're sitting here, you're doing 4 times 4 is 16, times 4 is 64, and then you have to figure out 64 times 4 to use up that last one, right? 4 times 4 times 4 is going to be 64, times another 4 is going to be 256, but that might be a little bit less obvious of a way to get to 256 than doing 16 squared. So that's all up to you. When you're actually doing the multiplication, it's your choice. I don't have a problem with you doing 16 squared this way, or 4 to the 4 that way. The only place where I would have a problem with it is that if I gave you a question with something like use exponent rules to simplify this down into a single power, and then work with that. So that would be like if I gave you something like 4 squared all squared, and I said use exponent rules to get it down to a single power, that means I want you to do it this way. But chances are I'm not going to ask you anything that specific. I might go back on that in a couple of weeks' time when I'm making up your test for this. But the thing is, there's no one right method, right? That's the thing I'm trying to sort of keep in mind as we're working through this, is that the method that I would solve a problem with might not be the method that you would use to solve the same problem, right? So sometimes you might be dealing with the stuff that's in the brackets first and then using the exponent out there later. You might use exponent rules to get it down to this and then deal with that. That's all up to you. Once you write out that string of 4s over there, you can multiply it however you like. I don't really care, as long as it gets you to the right answer. Alright, so hopefully that's clear and that's making sense, and is sort of refreshing your memory with some of the exponent rules that we were talking about before. So now we're going to introduce one more, and that's dealing with negative exponents, which is something that so there's, just that the same way that we've got positive numbers, negative numbers, we've got 0, which we talked about yesterday, having 0 as your exponent. You could even have fractional exponents, decimal exponents, whatever. But so we've talked about positive exponents, and we've talked about having an exponent of 0, but what if you had a, some number, to the exponent negative b? So if b is a positive number, then it would be negative 3 or something. So yeah, and basically the point I'm trying to make is that you've got a negative exponent up there. How do you deal with that? So the thing that's important to know here is that if you've got your base, some number, I don't care what it is, and your exponent is negative, that's the same thing as a fraction where your numerator is 1 and your denominator is the same thing that you started with, except for the minus sign. So, like that. So hopefully you see the difference here. So we started with a to the exponent negative b. So that's the same thing as a fraction, where now I've moved this whole thing to the denominator. I've taken away the minus sign. I'm left with just a to the b, and my numerator for that fraction is 1. Similarly, if you had a to the exponent b, this one is maybe a little bit less useful, but this is also true. That's the same thing as having a fraction where your numerator is 1, and then your denominator is the same thing that you started with, except for a minus sign. So basically, you can take your power here, and you can throw it into the denominator of a fraction, and just change the sign of the exponent. So if it was a positive number here, then it'll be a negative number there. If it was a negative number to begin with, then it'll be a positive number once you throw it in the denominator. So we'll do a couple of examples with this, just so you can see what I mean. So I'm going to leave that first form up there because it's probably slightly more useful. So let's first do 3 to the exponent negative 2. Is that the one I was working out earlier? Yes. So 3 to the exponent negative 2. So what that's going to mean is I'm going to have a fraction where my numerator is 1, and then my denominator is the same thing that I started with, so my base is 3, and my exponent was negative 2, but so I'm going to make my denominator everything that I started with, but just change that minus sign. So instead of having an exponent of negative 2, I just have an exponent of positive 2. So then that means that I've gotten from 3 to the exponent negative 2 to a fraction of 1 over 3 squared. And then I can turn that into, well, 3 squared is going to be 3 times 3, which is equal to 1 over 9. Alright, hopefully that's making sense. So that's basically how this works. I'll do one more example of it. And I'm going to erase the rule this time. I'll leave that example there in case you want to copy that one down. Let's do another one. So we've got 6 this time, let's say, to the exponent negative 3. That's what we want to work with. So in this case, we're going to take, first we're going to turn this into a fraction. So we've got our numerator of 1, and then our denominator, we have the same base, and then for our exponent, we just get rid of that minus sign. So instead of having negative 3, it'll be positive 3. So I've taken the thing I've started with, I've thrown it into the denominator, the numerator is just 1, and now I can go ahead and figure out what that denominator should be if I want to get it into just one number. So then I take that from 6/3, that means it's going to be, or not 6/3, 6 cubed, or 6 to the exponent 3, that's the same as 6 times 6 times 6 on the bottom. And you can go ahead and do that calculation. You'll get 6 times 6 is 36, multiplied by 6 again should be 216, if I'm doing that right. So that should be 1 over 216. We can always go ahead and check that as well. So we had 6 cubed. We know 6 times 6 is 36, and then to double check that, 6 times 6, that's 36. 6 times 3 is 18, plus 3 is 21. Yeah, 216 would be your denominator. Alright, so hopefully that's making sense. Let's move on to a couple more practice problems. But now we're not going to be introducing anything new now. We might introduce something new towards the end of the video, but we'll see how we're doing for time. Yeah, so let's do a couple of practice problems, and now we're going to use some of the exponent rules that we were talking about before. So we'll start with this problem. So we'll start with 3 squared multiplied by 3 cubed divided by 3 to the 4th. So if we're following the order of operations, we have to deal with exponents first, which means that we would have to compute 3 squared, which is 9, multiply it by 3 cubed, which is 27, and then divide it by 3 to the 4th, which should be 81. But we're going to make use of our exponent rules and mess with this a little bit so that it's something a little bit easier to work with. So the first thing we're going to focus on is, by the order of operations, we do multiplication and division in whatever order they appear in first, going left to right. So we'll start with this multiplication, and we know that if I've got the same base but different exponents and they're multiplied together, then my answer will still have the same base, and I'm just going to add those exponents together. So to do that, I've got 3 squared times 3 cubed, so my answer is still going to have a base of 3, that's not changing. And then because this is being multiplied together, I'm just going to take those two exponents and add them together. So 2 plus 3 is going to give me 5. So now I've got 3 to the exponent 5. And then I'm going to take that and I'm going to divide that by 3 to the exponent 4. And so now it's the same idea, but instead of using that multiplication rule, we're going to use the division rule, which is that if you've got two numbers with the same base but different exponents, and one is divided by the other, then you just subtract those exponents. So we were talking about that last time out as well. So now I'm going to make use of that rule here. I've got the same base, it's a division problem, so I'm going to just take those two exponents and I'm going to subtract. Now remember, the order matters. It has to be the first exponent minus the second exponent, because the order matters when we're doing a division problem. So that's going to leave me with 3 to the exponent 5 minus 4. We can simplify that exponent down. 5 minus 4 is 1, so that's just 3 to the exponent 1. And then we saw in the last video that you can simplify that down to just whatever number you started with, which is 3. So if we'd gone about it the other way, if we'd followed the order of operations, by the letter, then we would have started with just calculating all of those powers because of all the exponents that we have, and we would have gotten 9 times 27 divided by 81, which should hopefully still come out to just 3. But this might be an easier way to actually get to 3. And if I gave you a problem like that, you're allowed to, if you can recognize that 9 is 3 squared, 27 is 3 cubed, and 81 is 3 to the 4th, you can change it into that, use exponent laws, get it down to something like this, and come up with your answer that way. So if it's something like a final exam question, I ask you to do something like that, you're more than welcome to do the long division, or the long multiplication and long division, but you're also more than welcome to do the exponent law stuff to get it down to maybe a simpler form, something simpler to deal with. We never had a number larger than 5 going this way, but you got numbers up to 81 if you're dealing with it that way, and then you've got to do all this division and multiplication and stuff. 27 times 9 is going to be a pretty large number, so lots of things to worry about there. Yeah, so you can use whichever method you prefer, but of course ultimately it's going to be up to you. So hopefully that's making sense. Let's do one more similar-ish example, and then we'll see how we're doing for time. This one we seem to be doing alright for time, so I'll introduce one more concept after that I originally actually hadn't planned out. I usually, before each of these lessons, either at work or just in my downtime at work or in my downtime outside of work, I'll draw up a few questions for us to work on and solve them by hand there, so that I can double check my answers that I get on the board in the evening. And so I only had all of the stuff that we've covered so far and this one extra practice problem worked out, but if we've got extra time, then I'll go over one extra little neat thing that you can do with exponents in case you guys come across it. So let's do this one more practice problem. So we've got 2 to the exponent 4 times 3 squared times 4 to the exponent -2. So this time it's all multiplication, right? We don't have to do any division of, like subtracting the exponents or anything. But you'll actually notice that we've run into a little bit of a problem because none of the bases are the same this time. Last time all the bases were 3, so we could just add the exponents together or subtract the exponents or whatever, and that would get us our answer. This time it's not going to be so simple. Now you could say, well, 4 is a power of 2, so maybe I could turn 2 to the 4th into like 4, like change the base into a 4 and then change the exponent to however that's gonna, it's just messy, it's not gonna work out the way that you think it will. You'll try, okay, well if I've gone up by 1 power, then I can decrease the exponent by, it doesn't work. This is not gonna get you what you want. It can get really messy, especially if you're dealing with larger numbers. Just note that 2 to the 4th is not the same as 4 cubed. But yeah, so be careful with that. So your best bet in this type of a situation is to just go ahead and compute some of those. So let's figure out 2 to the 4th, that means 2 times 2 times 2 times 2. We write on the base, which is 2, 4 times because of our exponent 4. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 to the 4th, that's going to give us 16. Now 3 squared over there, well that's just 3 times 3, so that's going to be 9, and we were multiplying those together, so I'll put a multiplication sign there. And then over here we have 4 to the exponent -2. Well, if you remember the thing that we just covered, that means I can rewrite that as a fraction with a numerator of 1, and then my denominator will be whatever I started with, except I'm going to change the minus sign. I'm going to get rid of the minus sign, so I'm going to change my exponent from -2 to +2. So let me rewrite that now. We'll rewrite this one more time. So we've got 16 here multiplied by 9 multiplied by, and then this fraction, well, we've got 1 over something. That denominator, 4 squared, is the same as 4 times 4, which is equal to 16. So we've got 16 in our denominator there. Now, remember that if you've got a fraction over there and you're multiplying all of these together, that this is technically 16 over 1, this is technically 9 over 1, so you could go ahead, multiply all those numerators together. You get 16 times 9 times 1, which should come out to 144. And then on the denominator, you'll have 1 times 1 times 16 is just 16, so you get 144 divided by 16, which will get you your final answer. Or you could notice that because these are all being multiplied together, if I can find any common factors between one of my numerators and one of my denominators, I can just go ahead and cancel those out. So if I do that, well, I've got a 16 on top, I've got a 16 on the bottom, I can just cancel those out. That's the same as 16 here divided by 16 over there. So that's going to leave me with, this thing is just going to become 1. I've got 1 over 1, that's just 1. Over there I've got 1 over 1, that's just 1. And then I have a 9 in the middle. So if I rewrite that, that's 1 times 9 times 1, right? Because this is 1 over 1, that's just 1. 9 over 1, that's just 9. 1 over 1, that's just 1. 1 times 9 times 1 is going to obviously give us 9 as our final answer. Okay, hopefully that's making sense how I got to that final answer from where we started. So you might notice that, some of these problems, they'll be a little bit harder. It's common, once you've been working with, okay, same base, different exponent, same base, different exponent, that you just completely forget when you see a problem like this, that the bases are different and you can't just go and add those exponents together. It's not going to be that simple. So sometimes you do have to do a little bit of the calculation first, and then maybe the numbers will work out nicely, and you can just cancel things out and be left with an answer that required relatively little work. If this was a different number, then you might have had to put in some more work to get there. If that was a 5 or something, then you'd be dealing with something else down there, and things get a little bit messy when you do it that way. But yeah, hopefully that's making sense. That's all the stuff that I'd actually intended to cover in this lesson, but we're done a few minutes sooner than I'd expected. I don't want this to become super long, but I will show you one more thing that might be useful when you're working with exponents. And so we're going to use the letter thing again, and then I'll give you an example. So if you wanted to raise a number to some exponent, so you had a to the exponent b, that's all well and good. But what if the number that you wanted to raise to some exponent was a fraction? So what if you had the fraction a over b, and you wanted to raise that whole thing to the exponent c? Well, if you put it in brackets, does that mean I have to do a divided by b first, and then I have to raise that to the exponent c? But like, what if this is a decimal? What if I got like, I don't know, what if I got like 7 divided by 5, and then I have to raise that, whatever answer comes out to it gets messy, right? It could get messy really quickly. You could get stuck with, if you had 7 over 5 all squared or something, then it's like, well, if I have to do 7 divided by 5 first, then first I'm going to get a decimal, and then I have to square that decimal answer, and it's just, it gets a little bit ugly. This one wouldn't be the worst one, maybe 5 over 7 would be worse. But it's not pretty. If you had to do this division first and then take that decimal answer, depending on the question, it could be a never-ending decimal, and then you're supposed to somehow square that. It just gets messy. The rule that you can use to sort of simplify your life a little bit there is that you take the numerator of your fraction and you'll raise it to whatever that exponent is. So we'll get a fraction where our numerator is a to the c, because our c is out there. And you just do the same thing to the denominator. You take your denominator and you also raise it to the exponent c. So you get a to the exponent c over b to the exponent c. That's basically how it works. So I'll show you an example of how that works in action. So let's say you had a fraction 2/5, let's say, and then you wanted to cube that fraction. So you wanted to raise it to the exponent 3. Now one way to do that is you start with 2 over 5. Well, you could do that division first. 2 over 5 is going to give you 0.4, and then you could sit there if you really wanted and do 0.4 times 0.4 times 0.4. That looks messy. I don't know if you want to do that, but I don't want to do that multiplication. So we'll use this property of exponents, and so we'll take that numerator, our 2 here, and we're going to treat that as our base. And so we'll make that the base, and the exponent will stay the same. So we've got 2, this numerator goes over there, and the exponent just carries over with it. And then in our denominator, we take the denominator here, and we'll make that the base for another power. And we take that exponent and just carry that exponent over down there. So you take whatever exponent is outside, and you can apply it to the numerator. So you turn this 2 with the 3 on the outside into 2 cubed, and then you also apply it to the denominator. So this 5 down here with the 3 up there becomes 5 cubed over there. And then you can go and calculate that, and if you wanted to figure that out, you get 2 cubed is going to be 2 times 2 times 2, which should be 8. And then you can do the same thing with 5 cubed. 5 times 5 times 5. 5 5s are 25 times another 5 should be 125. So then you could get your final answer of 8 over 125. Alright, hopefully that's making sense. This little last bit I wasn't really planning on including. I might not focus too much on it when it comes to your assignments and test questions and things like that, but it's just a neat thing to know. Sometimes it might come in handy for you. A lot of these things, a lot of these properties of exponents, they sort of, they tend to be really, really useful if you're doing math that's just involving a whole bunch of letters, and you're asked to reduce something, or it's more practical to solve the problem if you reduce it to the simplest possible way you can write it down. the least number of things you have to write down, it's useful to know that you could take something like this and turn it into that. Or if you're trying to solve a problem, it's useful to take something like this or something like this with all the numbers, turn it into that, and get your final answer that way. So of course, there are different uses to it. Obviously, teaching through the whiteboard, it's a little bit harder to go over like word problem type, scenarios with you guys through this. I might try and start putting some word problems and things like that on your assignments, but I really want you guys to just sort of understand the math and try and sort of see where these things tend to be useful. But I will see if I can get some more word problems out especially when we get into more obscure stuff. Because right now we've been really sort of covering the basics, multiplication, division, fractions, decimals. We encounter these things on a reasonably regular basis. Exponents, also a bit, but less so than the others. But then, after this unit, we're going to start getting into stuff that a lot of people will never see outside of a math class. So maybe I'll start throwing in some word problems. You guys will have to work out, what information in the problem is useful, what information am I throwing out at you just to confuse you, all things like that. So that's all stuff for down the road. Don't worry about that yet for your assignments and stuff. Right now, just focus on understanding the math. Hopefully, this is all clear enough. But yeah, so those are some more practice questions and some more properties of exponents. Your assignment, I need to still make that, but your assignment will be coming out in the near future. And like I said a video or two ago, there's potentially a surprise headed your way, which you guys will know about in hopefully the next few videos. But yeah, if you guys have any questions, get in touch with me. Otherwise, I will see you in the next lesson. Have a good one.